Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm your teacher Simi Nabe, and I'm again here with a new lecture. As you know, dear students, social distancing and self isolation are effective ways to slow down the spread of this COVID pandemic. So I hope you must be doing well, inshallah. Let's start the lecture. This is my lecture number 7 for grade 7, uh, and we have to study geography. So we will continue with chapter number 2, which is Earth Alive. And as you know, that wind, water, and ice erode and shape of the land. Volcanic activity and earthquakes alter the landscape in a dramatic and often violent manner. And on a much longer time scale, the movement of Earth's plate slowly reconfigures oceans and continents. That's why we say the Earth is alive. In the previous lecture, we learned about volcanism. And I've told you that volcanism is the phenomena of eruption of molten rock, which is called magma, onto the surface of the earth. And we learned the types of the volcanism and even the classification of volcanoes. We also learned that volcanoes can be classified according to the frequency of their eruption. Volcanoes are classified as active, dormant, or extinct. Active volcanoes have a recent history of eruptions. They are likely to erupt again. But dormant volcanoes have not erupted for a very long time but may erupt at a future time. But the extinct volcanoes are different, completely different, and they are not expected to erupt in the future. And then we learned about the volcanoes in Pakistan, and I've told you the types of volcanoes found in Pakistan are mainly mud volcanoes. And Balochistan has more than 80 active mud volcanoes, and the world's largest and highest mud volcano can also be found there. And even I gave you a visit to the world's highest and largest mud volcano in Balochistan. And I've told you that mud volcanoes are not magmatic volcanoes. They are generally passive, they are emitting gases that bubble passively in their craters. However, they can also erupt powerfully, spewing hydrocarbon gases and tons of mud hundreds of meters into the air. Then I told you that there are some risks and benefits of living near the volcanoes. And these were like falling rocks, volcanic bombs, and projectiles, ash, and cinders at the time of eruption. So that is the risk. Again, the hot lava from the volcanoes flow down the slopes at high speeds, destroying homes, damaging infrastructure, killing people. That is again a risk. And it can cause air pollution. It can cause landslides. But there are some benefits, like it can give us the fertile soil. The geothermal energy can be found from volcanoes. Then there are precious minerals that we can found there, and it can also give us the scenic beauty that may attract some of the tourists. Like in Balochistan, we have the world's largest and highest mud volcano, which is really a center of point for many of the tourists in the world. So for today, we have a new topic, that is earthquake, and in your book it is on page number 22. An earthquake is the result of a sudden release of stored energy in the Earth's crust that creates seismic waves. In its most generic sense, the word earthquake is used to describe any seismic event, whether a natural phenomenon or even an event caused by humans, that generates seismic waves. Introduction of earthquake. Earthquakes, also known as the quake, the tremor, or the tremor, is the phenomena where there is a sudden release of extreme energy from the earth crust, resulting in shaking and displacement of the ground, along with the creation of seismic waves. Tremor or tremor, or we can say quake, means shaking or vibration. If the epicenter of a large earthquake is situated in the offshore, on sea or ocean, seabed may be displaced sufficiently to cause tsunami. It also triggers landslides and occasionally volcanic eruptions. It may cause loss of life and destruction of property. In a strong earthquake, the ground shakes violently. Buildings may fall or sink into the soil. Rocks and soil may move downhill at a rapid rate. Such landslides can bury houses and people. Earthquakes are tremors or vibrations that have occurred in the Earth's crust. They occur when there is sudden release of stored up energy in the Earth's upper mantle. Earthquakes occur most frequently at plate boundaries where plate slides past each other. Yeah, we can say a fault line. They may be converge or diverge. Converge means to connect when they are moving towards each other, or diverge when they are splitting. They are drifting, or they are moving away from each other. Another name for earthquakes is tremblers. It means shaking or vibration. The point at which an earthquake takes place is known as focus. Focus is the exact point where the magma was stored. This could be deep inside the crustal plate or near the Earth's surface. The vibration radiates from the focus in all directions as seismic waves. The place on the Earth's surface directly above the focus is known as the epicenter. After an earthquake has occurred, aftershocks that follow the first earthquake are very common. Aftershocks are the short periods or short magnitudes of earthquakes. So let me explain all the terms that are used here one by one, like epicenter, like seismic waves, like this focus, and many more. As I have explained earlier, that earthquake is the vibration of the earth produced by the rapid release of energy. The seismic waves are waves of energy that travel through the Earth's layer and are a result of earthquakes, volcanic eruptions, magmatic movement, or large landslides and large man-made explosions that give out low-frequency caustic energy. So energy that is moving outward from the focus of an earthquake, that is seismic waves, and then focus is the location of initial slip of the fault where the earthquake's origins, that is exactly the point, is called the focus, and epicenter is the spot on Earth's surface, that is a spot on the surface of the Earth but directly above the focus. How earthquakes are measured? The earthquake is measured according to the magnitude or intensity of the shock. Magnitude or intensity, shiddat, of the shock. Shiddat of the movement. The magnitude scale is known as the Richter scale, and the magnitude relates to the energy released during the quake. It is expressed in absolute numbers. Its range is from 0 to 10. They are recorded by an instrument called the seismograph. In your book, you can see on page number 23, some earthquakes are very strong while others are weaker. Scientists use an instrument known as the seismograph. And here is your figure 2.17. This is a seismograph and its parts. You can see the upper part is a frame. The frame to hold the rest of the part. Then we have a wire. Then is a pendulum, which is a kind of weight. Then is pen. Then is a paper drum, which is rolling. The paper drum is rolling, and there is a pen that is having marks on the paper. Then is a base. to hold the drum. And then we can see the tracing of vibrations. With vibration, the, the pen moves and it gives us the tracings so that we can see how mm, uh, severe it was, like what was the intensity or the magnitude of the earthquake. The magnitude or the amount of energy released by an earthquake is calculated using the Richter scale. It is a logarithmic scale where the numbers on the scale measures factors of 10. You know what is a logarithmic scale? It is a way of displaying numerical data over a very wide range of values in a compact way, a type of graph. Typically, the largest number in the data are hundreds or even thousands of times larger than the smallest number. And here you have on your in your book on page number 23 on figure 2.18. It shows a logarithmic scale. On this scale, a 6 means that the tremor is in this earthquake is 10 times greater than a scale of 5. From a scale of 5, the tremor is greater 10 times in a scale of 6. And the amount of energy released is about 32 times greater. So that is a specific unit used by a seismograph. This 2.18 shows the effects of an earthquake is measured by a Richter scale, while in the table 2.18b you can see provides description for the values on the scale. Like in a Richter scale, and you can see in the table below, in a Richter scale 1, it is not noticeable by people. But in a Richter scale 2, it is still not noticeable by people. In a 3, again not noticeable by people. But in 4, it felt by people inside the house, windows may rattle, slight damage. But in a 5, Richter scale 5, you can see people may run outside the house and furniture may move, moderate damage. In a Richter scale 6, poorly built buildings may collapse, considerable damage. And in a Richter scale 7, many buildings collapse, bridges collapse, serious damage. And a Richter scale 8 to 10, most buildings collapse and tremendous damage. So that's how we can measure the earthquake. So let me explain this instrument again here. When the earthquakes are measured by this instrument, this is called the seismographs. It has a base that sets firmly in the ground and a heavy weight that hangs free. The heavy weight is also known as pendulum. When an earthquake causes the ground to shake, the base of the seismograph shakes too. But the heavy weight does not. The springs that it is hanging from absorbs all the movement. And this recording is known as seismogram. So now on page number 24, there's a topic earthquake zones in the world. The earthquakes usually occurs at the boundaries of crustal plates and within areas with frequent volcanic activities. The areas with the highest frequency of earthquake occurs in the volcanic Pacific Ring of Fire zone around the Pacific Ocean, along the northern border of the Pacific Plate. Other areas such as the Mediterranean region and the Himalayas are areas in Asia, are also areas that experience high numbers of earthquakes. You can see in this figure 2.19 below, that shows the main earthquake zones in the world. So this is the another figure that shows major earthquake zones in the world, and you can see there are a lot of red dots which shows a shallow zone. The shallow focus points, and then we have some green points, few green points, and that are the intermediate depth, that having intermediate depth, and some of them are blue and purple. You can see blue and purple points, and their focus points are very deep. So on page number 25, you can see that thousands of earthquakes occur around the world each year. The magnitude of an earthquake indicates the amount of energy released by the earthquake. The greater the magnitude, the greater the amount of energy released by the earthquake. The magnitude of an earthquake can be measured by a seismograph, which is shown before. In contrast, the intensity of an earthquake cannot be measured by any instrument. The intensity, I told you, intensity is the shiddat of the earthquake that cannot be measured by any instrument. So it is dependent on the description of the extent of damage caused by an earthquake. For example, an earthquake rated an intensity of 1 has no impact on anyone else. People do not feel anything, any earth movement. While an earthquake rated an intensity of 6 is one where everything can feel movement. Objects fall from shelves, plaster walls might crack. If the damage from an earthquake is described as almost everything is destroyed, the ground moves in ripples, then its intensity would be rated 12. So that may be like the great intensity with a major intensity, a strong intensity, a moderate intensity, light intensity, or maybe very minor intensity. So factors that determine the intensity of an earthquake. The first one is the magnitude. An earthquake with a higher magnitude will cause more damage than one with a lower magnitude. An earthquake with a magnitude of 2 would do much less damage compared to another with a magnitude of 8. How strong the earthquake feels to observer, and the magnitude is related to energy releases. The intensity is the qualitative assessment of the kind of damage done by an earthquake. The intensity depends on distance to earthquake and strength of earthquake, and it's determined from the intensity of shaking and damage from the earthquake. Magnitude is quantitative. It's a quantitative measurement of the amount of energy released by an earthquake by a modern seismograph. It depends on the size of the fault that breaks, and it determined from the seismic records. Then the second factor is the seismic shaking. This is also known as the seismic ground motion. The seismic shaking is caused by seismic waves that are generated during an earthquake. The extent of damage caused by a seismic shaking depends on the duration, how long the ground was shaking, and the frequency of the seismic shaking. The higher the frequency of the seismic shaking, the greater the earthquake's intensity, hence the higher the damage. Another factor is the distance from the epicenter. It means like the focus. I told you that focus is the hypocenter in the point within the earth where an earthquake rupture starts. And the epicenter is the point directly above it at the surface of the earth. So the seismic waves reduce in intensity the further they travel away from the epicenter. Therefore, damage to places near the epicenter are more extensive than damage to places further away from the epicenter. Another factor is the building material. The building materials, here we can see the buildings built on the foundations made of stones are more likely to withstand seismic shaking and are less likely to collapse. Sometimes the foundations of the buildings can be built with shock absorbing material like rubber. and are flexible enough to withstand and absorb the shock waves that results from an earthquake. You can see in this figure the windows of the house can be made with type of glass that do not shatter during an earthquake. Wood and steel are better material to withstand earthquake than concrete and bricks. So the last factor that determines the intensity of the earthquake is the hazards caused by an earthquake. The densely populated settlement located near the seas or mountains experience a great extent of damage by earthquakes, as tsunami and landslides are more likely to occur in these localities. Like areas on the coastal areas, people living on the coastal area will experience tsunamis, and people living in the mountainous or the hilly areas will experience the landslides. An earthquake that occurs in the oceans can generate waves which can reach heights of up to 10 meters. These tsunamis can devastate large areas of land. Now, on page number 27, you can see earthquake in Pakistan. Pakistan has also experienced a number of earthquakes in recent years. 7.6 earthquake, known as the Great Pakistan Earthquake or Kashmir Earthquake, took place on October 8, 2005, and the 8.52 am earthquake's epicenter was located about 19 kilometers from the city of Muzaffarabad in Kashmir. The two provinces that were most affected were Pakistani administered Kashmir and the Khyber Pakhtunkhwa. This was the Pakistan's 13th deadliest earthquake, and the two most affected provinces, which were like the Pakistani administered Kashmir area and with Khyber Pakhtunkhwa, they both are located at the boundary of the continental Eurasian plate and the oceanic Indo-Australian plate. As the Indo-Australian plate subducts below the Eurasian plate, a friction force is created and energy builds up. Over time, the stored up energy becomes too great, resulting in a sudden release of stored up energy and a massive earthquake. As this earthquake's epicenter was located in densely populated areas, the extent of damage was severe. Other reasons for the earthquake's devastation include the focus of the earthquake was only 26 kilometers below the Earth's surface. So the depth was only 26 kilometers below the Earth's surface, and resulting in the massive shock waves that still continued their energy when they hit the densely populated area. The magnitude, which is like 7.8, or in your book it is 7.6 magnitude of the earthquake, was not only released tremendous geologic energy on the cities, but the main earthquake was also followed by a series of large magnitude aftershocks. Now I told you aftershock is a series of small durations with small intensity or small magnitudic uh, mm, earthquakes. The buildings in those densely populated areas which served as homes, schools, shops, and offices were poorly constructed. Many of these buildings could not withstand the severe tremors of the earthquake, and they collapsed. The extent of damage to the physical infrastructure of the province capital of Muzaffarabad resulted in a high death toll. Among them were children who were in school buildings at the start of their daily lessons. The people were not prepared for any earthquake. For example, there were no earthquake drills and no proper system of emergency food, water, and medicine supplies. The earthquake drills means like they were not prepared for any practice for their safety. The number of people who died as a result of the earthquake and its effects was about nearly 80,000. Some of the villages in nearby areas were completely destroyed. It was estimated that more than 3 million people were made homeless. Landslides prevented rescue people from reaching the affected people who lived in the mountainous areas. The effects of the earthquakes were too much for the government to handle alone. International aid in the form of food, medicine, tents, and blankets from many countries poured in. Poured in means they reached in. And rescue workers from many countries also came to help to rescue those who were trapped into the collapsed buildings. In Kashmir, the districts of Muzaffarabad, Bagh, and Rawalakot were the most affected areas. So, in the known historic and recent records, not one of the earthquakes in the Himalayas has ever produced a surface rupture, not in Nepal or India or anywhere. This rupture was the first one. Sudden and rapid releases of seismic stress can cause large earthquakes, and sometimes an abrupt movement along a shallow fault can rupture the surface, as happened during this 2005 Kashmir earthquake. The surface rupture extended for 75 kilometers and was the first among earthquakes in the Himalayas seismic zone. It was 30 to 45 seconds of a strong shaking. Muzaffarabad suffered great damage. The city of Balakot was almost totally destroyed, and the distribution of subsequent aftershocks in the Balakot, Batagram, Alai, and Bishram Kila areas suggests that the fault rupture extended in the northwest direction. Thank you so much, dear students, for watching this video. I'm not going to give you any assignment today, as I'll come again in another lecture with your assignment, your question answers, with few objective worksheets. So we'll do it next time. And um, if you have any problems, any queries, you can ask me. We are done with this chapter. We will do only the written work in the next lecture. Thank you so much. Bye.